In this episode of Circular Dimensions, we'll be applying stress to the two-dimensional universe example of the prior episodes. Just like a soap bubble is not a perfect sphere, the donut universe also wobbles and is imperfect. This movement generates surface stresses, namely regions of compression and regions of tension. Light traveling through compressed regions will travel faster than light traveling through stretched regions. This means light traveling in opposite directions will travel through the same space, but at different times. Thus, they will experience different stresses. This is the confusion generated when considering the fluidic property of the universe instead of a rigid linear structure. The animation does away with the wobbly donut and focuses on the stresses generated from the donut's changes in shape. The red regions represent areas of compression. The blue regions are areas of tension. The green regions are relaxed areas and represent areas of little to no stress. The dots are placeholders showing laps around the donut. The time wave and surface stresses are actually traveling back in time, because we are looking for all possible pathways to our sun, shown in the middle. The impact angle then shows the location and phantom locations for the perceived origins of that cyclical image. The dark circle is the time wave traveling on the perfect donut. The white circle is that same time wave as disturbed by the stresses across the fluidic surface. Note, not only is speed an issue, but also refractance, the bending of light due to dimensional stresses. Further, while time is applied for the first time within the animation to affect the structure during the process, the images discovered and marked as white dots are stagnant pictures. These would move around as multiple time waves return to the source. We witness this in our heavens as the twinkling and shifting of stars. Nearly half the stars in the Tycho's database have inaccurate parallax computations, distance measurements. We attribute this to human error in the angular measurements. However, it can also be due to the movement of dimensional stresses, which causes the star images to migrate, similar to thermal mirages. This adds yet another complexity to this brilliantly simple design. The dark dots within the circle are the laps as an observer would record them. The white dots are these cyclical images as experienced by the inhabitants. By applying one property, look at the wild dispersion and disruption of the uniform star field. Removing the stress plane, the image is clearer. The white dots represent the stars in heaven. Notice how even a single lap generated multi-star systems. And some laps did not produce stars due to the prismatic distortion splitting the light or being shielded by an image of a prior lap. Note, gravity mirages have not been considered. These would distort the field further and generate more phantom stars. In our heavens, we also measure distance to stars by measuring red and blue shift of the received light. This shift can also be caused by the refractance of the light through the dimensional stresses. Again, circular fluidic dimensions are providing answers and displaying them graphically. The next episode, Heaven, will examine our space and compare the star image we experience to the one generated here. Visit the link above for more information and links to all episodes in this series.